Hello everyone. In this presentation, I want to explain the SumCheck protocol. So the problem is that uh, how a prover can convince a verifier that she accurately calculate the sum of the evaluation of a function like g over all possible inputs value consists of 0 and 1, replacing for the variables b1 to bl. For instance, suppose we define the function g b1 to b5 as 2 b1 to power of 2 plus b2 plus b1 b2 b3 minus b4 plus b2 b5 to the power of 3. So this function has a different evaluation for all possible combination of 0 and 1 for the variables of b1 to b5. And the question is that if the prover calculate all of this evaluation, sum all of this evaluation to each other, which is 44 for this example, how the prover can convince the verifier that the calculate value for sum 44 here is correct. Yes, the naive solution is that the verifier could calculate the sum himself, but this is time consuming. We need a more efficient algorithm for this goal. So the SumCheck protocol provide a solution for this problem. Here is the SumCheck protocol. It is explained generally. So in the start, prover sends the claim answer C1, which is the required summation to the prover. And then later on, there are L rounds of interaction between the prover and verifier, which L is the number of variable of the function g. And after L rounds of interaction, the prover can convince the verifier. So here, we want to use this protocol on the previous defined function g in an example to see that how the protocol works. So this is the function g, which is defined already, and this is different evaluation of function g. So in the first step, the verifier share the function with the prover and then ask what is the summation of all evaluations. In round one, the prover first calculate the required summation, which is C1. So this means that the prover needs to open the summation over all the variables of B1 to B5. Then B1 and B5 could be 0 and 1. And after opening this different sum, the prover can reach 44 as the required summation. So prover need later share this value with the verifier, but this is not enough because verifier doesn't know that if prover really calculate this summation or not. So that's the reason prover needs to do some extra calculation and then share the result with the verifier. For the extra calculation, the prover needs to define h1 x1. This is a repetitive step in different interaction, in each round, prover needs to form function hi xi. So in this round one, prover formed the function h1 x1 by replacing b1, the first variable of function g by x1. So this means that prover needs to hold this variable fixed and then calculate the summation based on the remained variables b1 to b5. So when b2 to b5 could be 0 and 1. So after this computation, the prover reached to a polynomial 32x1 to the power of 2 plus 4x1 plus 4. Since we assume that the prover may cheat and do not share the accurate function h1 x1, so we use a different notation as s1 x1. So we expect that s1 should be equal to h1. So the prover later sends c1 as the summation of the evaluation and also the coefficient of polynomial s1 to the verifier. On the verification side, the verifier forms s1 x1 using the received coefficient, and then he calculates s1 0, which equals 4. So here, if the verifier replace x1 with 0 and x1 to the power of 2 with 0 and x1 with 0, then s1 0 would be 4. And also verifier needs to calculate s1 1 by replacing x1 with 1, which is 40. And we see that this equation is correct. S1 0 plus S1 1 should be equal to C1, which is the required summation. So this means that the first check is approved, but this is not enough. We need to go for the next round. In the second round, the verifier chooses a random variable, a random value for R1, which is 93 here, and sends it to the prover. The prover formed the function gr1 x2 b3 b4 b5 by replacing b1 with r1 and b2 with x2. Later, the prover should calculate the sum of the evaluation of function gr1 x2 b3 b4 b5 over all possible inputs. Values consist of 0 and 1 for b3, b4, and b5. So this means that the prover should fix the first two variables and then replace B3 and B4 with 0 and 1, and then open the sum and calculate to reach the final equation. So again, by replacing R1 with value of 93, the prover which reach to S2, X2, and then similar to the previous round, the prover should send the coefficient of the polynomial, which is 352 and 115,596 to the verifier. Similarly, on the verification side, the verifier form S2, X2 using the received coefficients, and then calculate S2 0 and S2 1. In addition, from the previous rounds, the verifier knows the function S1, X1 from the previous round. So then the verifier could calculate the value of S1, R1. So the sum of S20 and S21 should be equal to S1, R1. And if you calculate these values, you will reach this number for both sides of equation. So the second test is passed, and verifier convinced that the prover correct everything right till now. So let's go to the third round. So again, verifier randomly choose a number for as R2, which is 35 here, and send it to the prover. So prover similarly generate function G R1, R2, X3, B4, B5 by replacing B1 by R1, B2 by R2, and B3 by X3. So here is function G. To form this function, the prover needs to replace R1, replace B1 with R1. So we have this one instead of 2, B1 to the power of 2, and R2 instead of B2 and other parts. So later, prover compute function H3 X3 by calculating summation for the variables B4 and B5. The only two remains variables should be replaced by 0 and 1. So this is the final result for function H3. And then by replacing variables R1 and R2 with values 93 and 35, the prover reached to S1, X3. So then prover will share the coefficient of polynomial S3 with the verifier. So similarly, on the verification side, the verifier form function S3, X3 using the received coefficient, and then calculate S3 0 and S3 1 and sum these values to each other. And since the verifier knows S2 function from the previous round. So verifier can calculate S2R2, and the value should be equal to summation of S30 and S31. So if two sides of the equation is correct, this means that the next round of verification is approved. So round 4 is similar to round 3 and round 2. So I want to skip explanation about this round because it is similar to previous two rounds. And then the final round, which is round 5, because we have 5 variables for polynomial g. So this means that there are 5 rounds of interaction between prover and verifier. So that's the reason round 5 is the final round. So for the final round, again, verifier randomly choose variables R1, which is 26 here, and prover calculates function g R1, R2, R3, R4, and X1, X5 by replacing variables B1 to B5. And then here H5 and H5, X1 is similar to G R1, R2, R3, R4, X5 because there is no remained variables to be replaced by 0 and 1 and then calculate any summation. So by replacing variables R1 to R4 with the previous variables of these values for R, so prover will reach to function S5, X5, and then again share the coefficient of this polynomial to the verifier. So similar to previous verification steps, verifier needs to calculate S50 and S51 based on the coefficient received in the round 5 and also calculate S4 R4 based on the received coefficient of polynomial S4 from the previous round, and then verifier should check that if these two values are equal to each other or not. So this is similar to previous verifications in previous rounds. And since this round is the final round, there is another verification, and we have such a verification in final rounds of SumCheck protocol. So in the final round, verifier needs to randomly choose a R5, which is 15 here, and then verifier needs to calculate GR1 to R5. So since verifier knows what is function G, so then verifier can replace the variables B1 to B5 by R1 to R5. And if variables replace these values with values of R, so the final evaluation would be this value, 178,447. So this value should be equal to value of evaluation of polynomial S5 on R5. So the verifier knows what is S5 from the received coefficient. So then verifier can calculate the evaluation of polynomial S5 on our file. And if these two values are equal to each other, so verifier would be convinced that the first received value of C1, which is 44, as the required summation uh, is correct. So this means that SumCheck protocol needs a round of communication between prover and the verifier to convince verifier that the summation was calculated correctly. So this SumCheck protocol seems very simple, but we have many applications based on this SumCheck protocol that we will discuss in later presentation. Thank you for listening and share any question with me. Thanks.